Namaskar. Ladies and gentlemen, please welcome on stage our chief guest, Dr. Harshavardhan, Honorable Union Minister for Health and Family Welfare, Science and Technology, and Earth Sciences. Dr. M. Rajivan, Secretary, Ministry of Earth Sciences. Dr. Vipin Chandra, Joint Secretary, Ministry of Earth Sciences. A very good morning to all of you. To start today's proceedings, on behalf of the Ministry of Earth Sciences, I would like to welcome you all to the celebration of 14 years of the Ministry of Earth Sciences and its Foundation Day 2020. Due to the unprecedented prevailing circumstances caused by the COVID-19 pandemic, the Foundation Day function is being organized in a very modest way, with physical presence being restricted. I would like to extend a warm welcome to all the former secretaries, former directors and colleagues from the MoES institutes and other dignitaries who are watching this program live from their respective places. I also welcome Dr. Margaret Lenin, Director of Scripps Institution of Oceanography, Vice Chancellor of Marine Sciences, University of California, San Diego, who is also watching this program live from San Diego. I would now like to call upon Dr. M. Rajivan, Secretary, Ministry of Earth Sciences, to deliver the welcome address.
Very good morning to all of you. Dr. Harshavardhan ji, Honorable Minister for Health, Science and Technology and Earth Sciences. Dr. Vipin Chandra, Joint Secretary, Mrs. Sumita Sarkar, JS and FA, my dear colleagues of MoES family, respected past secretaries of DOD MoES. First of all, my hearty congratulations to all of you on this 14th Foundation Day of the Ministry. I want to specially thank our Honorable Minister, Dr. Harshavardhan ji, for sparing his valuable time and participating in this function. As you know, that the last 5 years, as the Minister of Earth Sciences, he has been providing us constant encouragement, guidance and support for all our activities. He has been always an inspiration for all of us. He is active in social media to make regular announcements of our achievements and our good work. We all should acknowledge his sincere contribution and support and thank him for the same. Thank you very much, sir. We have been celebrating this Foundation Day in a grand manner for last several years, but due to COVID-19 situation, today we are bound to organize this function in a small way. As our father of the nation, Mahatma Gandhi, suggested, he has mentioned about 7 deadly sins. For example, business without ethics. As far as science is concerned, he told science without humanity is a deadly sin. Science should meet the needs of society. Doing science without any societal commitment is really meaningless. Our Ministry of Earth Science is very much committed to deliver many useful applications for society with the help of good science and technology. As you are aware, due to COVID-19, many restrictions and lockdowns were implemented throughout the country, except for the essential services. The work being done at IMD, INGOIS and NCS are considered to assess the essential services. I am happy to inform that in spite of huge hardship and difficulties, especially in traveling, IMD and INGOIS and NCS could sustain the essential services of weather forecast and warning, ocean state forecast, tsunami warnings, and also earthquake monitoring without any difficulties. No serious impacts on quality of forecast and services could be noticed due to this lockdown. So I should thank all the staff and officers of IMD, INGOIS and NCS for their dedicated work during these lockdown periods. I also thank IATM and NCMRWF also for providing the services of HPC, high performance computers, uninterrupted during this difficult time. You may be remembering that during this lockdown period only, IMD could make excellent and accurate predictions of 2 cyclones. One is Umphan, and next is Nisarga. It went to Maharashtra. We could save thousands of precious lives. As you are all aware, we have been doing excellent work in all areas of our mandate. I will not go through the details, but briefly mention about a few things. For example, improved cyclone forecast last few months, cyclone Umfan and as well as Nisarga. In general, improvement in weather forecast. For example, our CFS forecasting scheme, our CFS forecasting system is put in now TIGI data set. It's really a global recognition. Very few models are taken up for putting in TIGI. So these data are available for the global community now. Northwest India radars we have been putting in. 2 radars have been already installed, and another few will come by this year. And we have Honorable Minister has inaugurated the Mumbai flood warning system. We also released recently the first climate change assessment report, which was prepared by our National Center for Climate Change Research in IIT in Pune. We have recently started potential fishing zone forecast, and especially giving a forecast for 2 states we started. And desalination plants, the 6 plants we are now working, and already 1 plant is completed, and remaining 5 will be completed in the next few months. Because of this COVID, we are not able to move the ships, etc., from Kochi or Mangalore to Lakshadweep Island, so there is a small delay. And solar-based desalination plant we have set up in Kanyakumari. New development in manned submersible as well as deep sea mining system. NIOT has been doing a lot of good work. And also we have been doing scientific expedition to all the 3 poles, and also seismic microsonation of cities. 4 cities already is in a good shape, and 8 will be implemented very soon. And we also commissioned 1 coastal research vessel as well as 1 Doppler weather radar. Our ambitious project, the Deep Ocean mission, is ready for launching after the approval of the Technology Board of Government of India, chaired by Professor K. Vijayaraghavan. EFC and cabinet approval is, however, some pending. During these lockdown periods when we are sitting at home, as also we are not moving out, we started a new webinar series for Earth Science subject. It's almost 30 now, and maybe 3-4 are remaining. And there are very impressive scientific presentations every week, twice in a week, 2 in 1 week. And these are all well received by the scientific community, and also we received a lot of appreciation from press and media. It was given in a very lucid, very simple language to make sure the people understand what we are doing. And our social media presence has also improved a lot. For example, I can give you 2 examples. For IMD's Twitter media presence is increased by 80% for the last 6 months. Now they have followers more than 1.23 lakh. It was there about 60,000 a few months back. Similarly, MoES Twitter account was also increased by almost 50% during last 6 months. And many new IMD officers now joined the social media, and they are very active in social media. For next few years, MoES has very ambitious plans. And for example, we will be procuring, if everything goes well, we will be procuring a new computer, HPC, high performance computer of 40 petabytes by next year. That will help us to generate global weather forecast at 5 kilometers, which can be used for block level forecast for helping farmers. Also, we are going to launch an urban meteorology program and regional forecast at 1 kilometer. And augmentation of Doppler weather radars from currently 28, we will be doing it to increase to 50. Already tender is almost ready. It will be out now in few days. Research test bed for Bhopal. We have got 100 acres of land from Madhya Pradesh government. We will be setting up a very unique research test bed in Bhopal for studying monsoon clouds. And we also, Northeast region, as you know, that our observational network as well as the forecast system have to improve. So we are going to have integrated meteorological services for Northeast region, focusing exclusively Northeastern states. And as I told, Deep Ocean mission we are going to launch. And development of manned submersible, we give a lot of priority on two technology development projects like manned submersible as well as integrated mining system. And we also will be, we already started work on OTEC plant, Ocean Thermal Energy Conversion Plant at Kavariti. And when it is completed, it will be India will be the first country to develop this OTEC plant in any part of the world. We will also strengthening our marine biology, biodiversity work. We will be setting up a marine biology station at Goa, with the support of Principal Scientific Advisor's Office. We have two research ships, Sagar Kanya and Sagar Sampada, which are almost 35 years old now. So we need to really replace. So we have already started writing EFC documents. And we are also trying to buy a polar research vessel. Last 4 or 5 years it has been going on. Hopefully it will also happen in the near future. But we are very determined to have a polar research vessel. And Maitri station also is very old, and we need to really replace the Maitri station in Antarctica. And as you know, the NCCR has been doing a lot of good work in coastal research. We need to really further strengthen. They have been doing a lot of work, especially beach restoration, etc. And in geoscience, we have to do a lot of strengthen the basic geoscience research, geodynamics, work on geodynamics, studies on landslides, etc. Same way, the marine living resources. So they have to also we are to be supported. The work on marine biodiversity also to be augmented. As far as seismology is concerned, we had few years back we had only about 80. So now the network is almost 115. So it will be increased to 150 now. 150 another 1 or 2 months. Already instruments have come. We have planned to increase to 300 very soon. And BGRL at Karad, we have been doing a lot of good work, and because of COVID and other some constraints because of the environmental clearance, etc., the work is going a little slow, but we are talking to Maharashtra government to get the clearance, etc., and that activity also will be now strengthened. We are setting up a Geochronology Center. It's one of the first in this country at IUAC in New Delhi. It is a UGC center. That will be, when it is set up, it will be a first of its kind in India. Already most of the instruments have come except one oscillator which is pending, so that will be, they will be purchasing by this year. And we have again some 50-acre land now adjacent to NCMRWF in Noida, so we are going to set up new facility there, new campus. We will have a new office for NCS. We will have a new IMD office, regional office in IMD. And also NCMRWF will have some facilities there. But we all have to adapt to more and more digital technologies. This is the now new way of life, and improve our IT infrastructure. This is the more focus we need to really do. Also, we have some important pending administrative reforms to do. The most important is to formulate a promotion policy for scientific and technical assistants working at IMD and also autonomous institutions of our ministry. Ministry is seriously pursuing with other ministries, especially with the finance ministry, to frame up a promotion policy for them. MoES gives the highest priority to bring out a promotion policy for technical staff as well as for administrative staff of ministry as well as institutions. We also acknowledge and appreciate the sincere work carried out by the scientific assistants and technical assistants at IMD as well as other autonomous institutions. We will do our best to bring a promotion policy for them very soon. And also, we know you are aware that MoES Foundation, we normally have a Foundation Day lecture given by eminent scientists. This year, we wanted to bring a very eminent women scientist, and so we requested Dr. Margaret Lenin. She is the director of the Scripps Institute of Oceanography. As you know, Scripps Institute of Oceanography is one of the best oceanography institutions in the world. She was really agreed to come. Because of this COVID restriction, she is not able to come. But she has already given us her presentation, which we will be broadcasting after this function. And she has agreed to deliver a talk. She will be talking on ocean science for the 21st century. And we should thank Dr. Margaret Lenin for this gesture. And we are also going to sign a MOU between Ministry as well as Scripps Institute on Ocean Research. It will be a new initiative. Definitely, that MOU will help us to improve our ocean science research. She has promised us to visit India once the present situation improves, and we look forward to her visit to India. And also, we know that MoES gives away annual awards at this Foundation Day. In this year also, we have finalized, even though COVID situation was prevailing, we finalized the MoES annual awards now. We received nominations, we got it approved through committees, etc. So both national awards for excellent research in areas of earth sciences as well as MoES Best Employee Awards. We thank all the expert committee chairs and members for working during this COVID crisis towards selection of these awards with a due diligence and care. Due to some administrative reasons, the MoES National Awards will be announced a little later. However, I will now read out the MoES Best Employee and Certificate of Merit Awards. We normally give awards on the same day, but because of this restriction, we are not able to give the awards. But I will announce the awards now today, and we should all congratulate all the award winners. Please give me some time to read these names and a few names. You should have some patience to listen the names, and we should all congratulate these people for getting these awards. One is Certificate of Awards for Atmospheric Science. One is Dr. Pula Guha Thakurta, he is from IMD. Dr. I think you can clap together afterwards, and after I read out all the names. Dr. Sanjeev Sen, Scientist F, he is from IMD. Sachin Gude from IITM Pune. Dr. Habibur Rahman Biswas, he is from IMD. Dr. Imran Ali M. Momin, he is from NCMRWF, and Arun Kumar Gupta from MoES. In Ocean Science, Babulal Jaina from NCPUR. Dr. Anbu Rajan, he is from NIOT. Dr. Abhishek Chatterjee from INGOIS. Dr. Reshmi from NSS. Dr. Sanjay Kumar Prajapati from NCS. Dr. V. Ramanathan from NCCR. And Dr. Hashim from CMLRE. And for Group B gazetted office, gazetted, non-gazetted, I'll just read Sri Anuj Kumar Dahiya, Section Officer, Dinesh Kumar Mete, ISSD, Kailash Mamgain, AO3 GS, Pradeep Sharma Mete, Anand Desai, Assistant Manager, Liji TM, Scientific Assistant, Veena Chanjalni, Srimati Veena Chanjalni, Sri Naman Preet Singh, Sri TV Rajesh, Sri Sandosh Kumar, Sri Pradeep Kumar Singh, Senior Executive, Sri V. Chandran, Scientific Officer Grade 2, Sri K. Ramesh, Scientific Officer Grade 2, Sri Sandeep Subhash Kulkarni, Senior Executive, Srimati Sheila Abraham, SA RMC Mumbai, Sri Madhuri Musale, SA Pune, IMD Pune, Sri Aglesh Kumar Jha, Scientific Assistant. Group C, Srimati Jayasri LDC, Mr. Aman Kumar Sarma, Executive, Srimati Rasi PC, Executive Director Cell, Sri Sulabh Srivastava, Sri Jawaharlal Das, Sri Putal Datta, Sri ML George, Mechanical Grade 1, Sri Pradeep Kumar VK, Fishing Hand. MTS, Sri Rajkumar MTS, Sri Rajendra Babu, Sri Vikas Vittal Bamble, Srimati Shamala KG Nair, Sri VD VR Prasad, Sri SB Singh, Sri Randir Singh MTS. Certificate of Merit, Sri BB Murthy, Scientist E in NIC, Arvind Pandey, PPS, and Sri Pramod Kumar of MoES. So now we can clap, and we should hearty congratulations to all of them. And a big thank you to all of you for your sincere and dedicated work, and we expect this kind of sincere work for the coming years, coming days, and we should remember that we have to deliver a lot, and a lot of expectation from both from government as well as common people on Ministry of Earth Sciences. As all of you know that we are going through a difficult time now due to COVID situation, crisis, but I should tell you, optimism is more contagious than COVID-19. So let us be all very optimistic for our future. We'll come out with flying colors, and our social and economic conditions will substantially improve very soon. With this hope, I will stop here. Please stay safe. Wish you all the best. Thank you. Jai Hind.
So on this occasion of this MoES Foundation Day 2020, we'll be releasing the IMD's MoSA mobile app in the presence of the Honorable Union Minister, Dr. Harshavardhan. We'll play a short video on this IMD MoSA mobile app now.
India Meteorological Department Ministry of Earth Sciences has taken various initiatives in the recent years for improvement in the dissemination of weather forecast and warning services based on the latest tools and technologies. To further enhance this initiative, Ministry of Earth Sciences feels proud to launch the mobile app MoES for India Meteorological Department. This mobile app is dedicated to the general public and designed to communicate the weather information and forecasts in a lucid manner without technical jargon. Users can access observed weather, forecasts, radar images, and be proactively warned of impending weather events. The MoES mobile app has the following 5 services. 1. Current weather, which provides the current temperature, humidity, wind speed and direction for 200 cities updated 8 times a day. Information on sunrise, sunset and moonrise, moonset are also given. 2. Nowcast gives 3-hourly warnings of localized weather phenomena and their intensity issued for about 800 stations and districts of India by state meteorological centers of IMD. In case of severe weather, its impact is also included in the warning. 3. City Forecast provides the past 24 hours and a 7-day forecast of weather conditions around 450 cities in India. 4. Warnings, where alerts issued twice a day for all districts for the next 5 days in color code red, orange and yellow to warn citizens of approaching dangerous weather. The color code red is the most severe category, urging authorities to take action. Orange code prompts authorities and the public to be alert, and yellow code prompts authorities and public to keep themselves updated. 5. Radar Products provides the latest station-wise radar products updated every 10 minutes. The MoES mobile app will be an important tool for dissemination of weather information and warnings in an attractive and user-friendly manner which will meet the requirements of the public. The mobile app has been designed and developed jointly by ICRISAT's Digital Agriculture and Youth Team, Indian Institute of Tropical Meteorology, Pune, and the India Meteorological Department.
This mobile app is available both on the App Store as well as the Google Play Store. Thank you. The next point on the agenda is the inauguration of the MoES Knowledge Resource Center Network. So on this occasion of this MoES Foundation Day, we will be launching the MoES Knowledge Resource Center Network in the presence of the Honorable Union Minister for Health and Family Welfare, Science and Technology and Earth Sciences, Dr. Harshavardhan. The Knowledge Resource Center Network is a web portal for the network of knowledge resources of the MoES headquarters and its 10 institutes. It's a single gateway to all the intellectual world of the Ministry of Earth Sciences Systems, and it will provide a 24/7 access to e-resources submitted under the Digital Earth Consortium of the Ministry. It will also give access to all our users the MoES Digital Repository, hosting the publications, research articles, the PhD thesis, videos from various MoES institutes on a single platform. And one of the most important things, it will give an access to the directory of the Indian Antarctic Expedition members. Currently, till date, we have had 39 expeditions to the Antarctic. And so this portal will have all the information and the related to the Indian Antarctic Expedition. A sample of this is shown here. So we have now made the directory for the first 11 expeditions to the Indian Antarctic Expedition, and very soon we'll be hosting the information of all the 39 expeditions to the Indian Antarctic. Once we complete this work, we also plan to form a similar repository for the Indian Arctic expeditions. Thank you, sir. Ladies and gentlemen, please join me in welcoming our chief guest, Honorable Union Minister for Science and Technology, Earth Sciences, Health and Family Welfare to address the gathering.
Dr. M. Rajivan, Secretary, Ministry of Earth Sciences, Dr. Vipin Chandra, Joint Secretary, Ministry of Earth Sciences, Srimati Sumita Sarkar, Dr. M. Mohapatra, Dr. E. Rajgopal, all other senior scientists, all the distinguished former secretaries of the Ministry of Earth Sciences who have joined us through the web, other employees of the and our very special guest today, to whom we have to express our gratitude also for joining us and also for delivering the keynote address today in spite of COVID, Dr. Margaret Lenin, Director Scripps, Institution of Oceanography and Vice Chancellor for Marine Sciences, United States, San Diego. Dr. Margaret, we are extremely grateful to you. I feel sorry that we can't meet. I can't even see you right now, but I know that you have joined us today. So we are extremely grateful and we really feel privileged. Of course, all my dear media friends are also here. Thanks all of you for being with us today in this function, which has been organized in an entirely different way. I think it's the new normal for the society, for institutions, for the academia, and maybe in the long run it might prove to be some sort of a blessing for us. We can probably with less resources, minimum input, we can have maximum output. A lot of people can join us without having to bother for travels and leaves and so many other things. So it's this way of communication was available to us earlier also. But COVID probably reminded us that this could also be another better normal for the society. So my dear friends, the Ministry of Earth Sciences Foundation Day is indeed a great occasion. And I am honored to be here with all of you to celebrate our 14th anniversary. As we all know, our Ministry of Earth Sciences was formed in 2006 by a merger of the Indian Meteorological Department, the National Center for Medium Range Weather Forecasting, the Indian Institute of Tropical Meteorology, the Earth Risk Evaluation Center, and the Ministry of Ocean Development. Friends, the earth science is a combination science that draws upon all other sciences to unlock Earth's mysteries. It is unique and yet interdependent. Earth science empowers us to think globally and act locally, to make sound decisions about issues important in our lives as individuals and also as citizens. People who understand how earth systems work can make informed decisions. They can debate and resolve issues surrounding clean water, urban planning and development, national security, global climate change, and the use and management of natural resources. In the 21st century, we need to be informed citizens, and earth science takes us exactly there. It serves to connect us all to each other biologically, to the earth chemically, to the rest of the universe atomically. Which is why I always say that the earth science skills become life skills, and therefore the earth sciences ministry can easily be seen as the life skills ministry. In fact, the study of all earth sciences is a humbling and character building exercise and an experience. To me, it underscores our responsibility to deal more kindly with one another and to preserve and cherish the pale blue dot, the earth, the only home we have ever known. In terms of contemporary impact, one of the most important areas of earth science is the study of climate change, the slow warming of the earth, the accompanying effect on biodiversity, and humankind's part in it, which must be addressed to protect the planet we all live on. Climate change resulting from over-exploitation of Mother Earth can no longer be denied. It can't be edited out. It can't be omitted from the conversation, which is what the planet is facing today. Not just because I am the health minister of the country, but because I am a responsible citizen of the world. I am compelled to admit that the present COVID-19 pandemic that has destroyed millions of families and wrecked the global economy is nothing but a result of the havoc that mankind has unleashed on nature and on Mother Earth over the last few centuries. Those who understand the way nature plays out and understand earth science know well what I am talking about. Our lives and civilization depend upon how we understand and manage our planet. Earth processes affect us all. Weather patterns influence the availability of water resources and the potential for forest fires. Earthquakes, volcanic eruptions, hurricanes, and floods can kill large numbers of people and cause millions or even billions of dollars in property damage. Just as earth systems directly affect each of us, we as individuals, communities, and nations affect our planet. Expanding technologies and growing populations increase demand on natural resources. As we extract and use these resources, we impact Earth today, which will in turn impact those who come after us. To enhance our stewardship of the environment, we must proceed into the future with a sound understanding of Earth systems. This ministry The Ministry of Earth Sciences is a unique organization in the world which looks holistically at all branches of earth science: atmosphere, hydrosphere, cryosphere, and lithosphere. India is the only country with a fully dedicated ministry solely addressing all the aspects of earth sciences. This helps in developing an integrated approach in planning and resolving major concerns in a holistic manner with least time delay. The ministry has attained many significant achievements in the recent past, which are considered to be of global standard for other countries to follow. On weather and climate sciences, India has one of the best weather services in the world for disaster management, with accurate warnings on tropical cyclones, heat waves, and floods. The IMD provides tropical cyclones and storm surge advisories to 13 member countries under the ESCAP panel. India has also developed an Earth system model for future climate projections for the first time. This model capability is at par with other modeling centers in the United States, United Kingdom, Australia, Japan, and Germany. Ministry of Earth Sciences has launched an experiment to understand and document merits and demerits of artificial rainmaking, cloud seeding, by conducting experiments with 2 aircrafts in 2 years. This experiment has collected 234 samples of clouds to demonstrate the efficacy of cloud seeding. The kind of large-scale cloud seeding experiments are carried out by very few countries like the United States. On the setting up of atmospheric research test beds, a unique facility in tropics will be launched in 2021 with the first phase of instrumentation. This open field observatory is planned to be spread over 100 acres of land 50 kilometers away from Bhopal, and is proposed for a better understanding of the monsoon, clouds, and land surface processes. This center will have state-of-the-art observational systems such as radars, wind profilers, UAVs, etc. Very few countries have these kinds of research test beds. We are also proposing the use of artificial intelligence, machine learning, and Internet of Things for data collection, analysis, and developing forecast applications, as well as more automation of observations and data analysis. I know that we are also planning better computing resources, HPC 40 petaflop by next year, for generating global forecasts at 5 kilometers and regional forecasts at 1 kilometer. ECM FW, for example, has gone for 1 kilometer global forecast, even though on research mode. On ocean sciences and technology, INCOIS provides one of the best services in ocean state forecasts and tsunami warnings to 25 countries for the Indian Ocean, with no false alarms till date. NIOT has pioneered the development of indigenous desalination plants for islands using green technology. This system can be transferred to other island countries like the Maldives. Another success story of this ministry lies in deep sea mineral mining. India is one of the very few countries involved in exploration of deep sea minerals. India is the pioneer investor with a contract with the International Seabed Authority. Ministry of Earth Sciences has also been seriously involved in research on deep ocean exploration for the last 30 years. India has been one of the first few countries in developing a deep mining system up to 6,000 meters, which is under testing now. Similarly, the National Institute of Ocean Technology has designed and developed many modules for manned submersibles which can go down to 6,000 meters. This is expected to be completed by 2022. Once completed, India will be the sixth country in the world to have manned submersibles for deep sea exploration after the United States, China, Japan, Russia and France. Ministry of Earth Sciences has one of the best ocean research fleets with 7 ships exclusively used for research purpose. On the seismological services and seismological research, the Deep Borehole Observatory at Karad in Maharashtra is one of the very few such observatories across the world. The 3-kilometer borehole is one of the deepest boreholes in the world. Ministry of Earth Sciences has established one of the best research facilities for geochronology at IUAC New Delhi. This facility would be capable of dating the oldest geological formations in Earth history and providing improved and quantitative understanding of the evolution of the Indian lithosphere. In addition, this facility would help in contemporary cutting-edge research in atmospheric, oceanic and planetary sciences at an international level. Similarly, on polar sciences, the National Center for Polar and Ocean Research, NCPOR, Goa is responsible for the country's research activities in the polar and southern ocean realms. We are the best in research in the Himalayas. We need to strengthen research activities in the Arctic and in Antarctica. At present, India is at 25th place in Arctic research and 16th place in Antarctica research. Friends, having elaborated on our success stories, I do simultaneously understand that there are many lacunae that need to be filled up for us to take a giant leap forward. We need huge financial investments, at least twice of the present budget, in augmenting observational networks, replacing old ships, procuring new computing resources, etc. I also understand from my scientist friends here that we also need more trained manpower. Earth sciences is a specialized interdisciplinary subject with expertise from physics, maths, meteorology, chemistry, geosciences, engineering and technology, etc. However, given all the constraints that we have been facing, we have done very well. Today, I take this opportunity to congratulate each and every person who has been associated with this ministry in the past as well as now. It would be an opportune moment for me right now to acknowledge the contributions of late Dr. Sikka, late Dr. Birbal Sahani, Dr. Ravindran, Dr. Sulochana Gadgil, Dr. Shailesh Nayak, Dr. P.S. Goyal, Dr. Harsh Gupta, Dr. V.K. Gaur, Professor J. Srinivasan, Dr. Satish Shinoy, and many others who have steered this department and the development of earth sciences in India. I would also like to bring on record the dynamic working of our present Secretary, Dr. M. Rajivan. I would also like to use this occasion to congratulate all the awardees whose names have been announced today and who could not enjoy the privilege of receiving them today. kudos to all our scientists. We have come a long way, and there is much more to be done. I shall end with my favorite verse from Robert Frost. The woods are lovely, dark and deep, but I have promises to keep. Miles to go before I sleep. Miles to go before I sleep. Thank you, my friends.
Thank you very much, sir, for your kind words. And I'm sure with your continued guidance, the Ministry of Earth Sciences will be able to achieve many more milestones in the years to come. I would now request Dr. Vipin Chandra, Joint Secretary, Ministry of Earth Sciences, to propose the vote of thanks.
Honorable Union Minister of Health and Family Welfare, Science and Technology and Earth Sciences, Dr. Harshvardhan ji, Secretary MoES Dr. M. Rajivan, my colleague Srimati Sumita Sarkar, JS and FA, former secretaries of DST, erstwhile DOD and MoES, colleagues from Ministry and MoES institutions, ladies and gentlemen. It gives me immense pleasure to propose the vote of thanks at the end of this MoES Foundation Day function. Firstly, I express my sincere gratitude to Honorable Union Minister for Health and Family Welfare, Science and Technology and Earth Sciences, Dr. Harshvardhan ji, for sparing his valuable time to be with us on this occasion. For last 6 years, he has been providing us guidance, inspiration, and excellent support in our activities. Sir, we look forward for continued guidance in implementing the various programs of MoES. I would like to assure the Honorable Minister that the MoES family of professionals will always be in the pursuit of acquiring advanced knowledge and dedicate themselves towards making the ministry as one of the best in the world in providing services on weather, climate, ocean, and seismology. We are extremely grateful to Dr. Margaret Lenin for sending the video recording of the Foundation Day lecture. It will be played after this function. I would also like to congratulate winners of Certificate of Merit for scientists, engineers, and winners of Best Employees Award from autonomous institutions, subordinate and attached offices of MoES. We would like to thank all our former secretaries, directors, colleagues from MoES institutions, friends from media who are watching this function live through webcasting. Last but not the least, I thank all my colleagues from MoES who have helped in organizing this Foundation Day function. Thank you very much.
Thank you.
I would request my colleagues to kindly be seated. before we start the next program. So we come to the next part of our program, where we have a lecture on the ocean science for the 21st century by Dr. Margaret Lenin, who is the director of the Scripps Institute of Oceanography, the Vice Chancellor for Marine Sciences in the University of California, San Diego. I'd like to introduce Dr. Margaret Lenin to the audience. She is a highly distinguished scientist as the director of the Scripps Institute of Oceanography at the University of California, San Diego. She also serves as the University of California, San Diego's Vice Chancellor for Marine Sciences and the Dean of the School of Marine Sciences. She received a bachelor's degree in geology from the University of Illinois, the master's degree in geological oceanography from Oregon State University, and a doctorate in oceanography from the University of Rhode Island. Dr. Margaret Lenin is an award-winning oceanographer and an accomplished executive with extensive national and international experience in ocean science, global climate, and environmental issues. She is a researcher in paleoceanography and paleoclimatology. Her work focuses on ocean sediments and their relationship to the global biogeochemical cycles and the history of the Earth's ocean and climate. Dr. Margaret Lenin leads the University of California, San Diego's Ocean, Earth, and Atmospheric Sciences Research and Education Program, the foremost environmental research institution that addresses the most pressing environmental problems facing our planet, provides the knowledge necessary to address these challenges, and teaches the next generation of science leaders. Dr. Margaret Lenin currently serves on the Executive Planning Group for the UN Decade of Ocean Science for Sustainable Development. From 2016 to 2018, she served as the US Science Envoy, focusing on ocean science in Latin America, East Asia, and the Pacific. She is a fellow of the American Association for the Advancement of Science, a fellow of the Geological Society of America, and has been awarded the Distinguished Alumni Awards for all the 3 universities she attended as a student at the University of Illinois, Oregon State University, and University of Rhode Island. I'd request all our colleagues to give an ovation to Dr. Margaret Lenin and welcome her for the speech. So we'll now play the video which has been sent by Dr. Margaret Lenin.
Hello, everyone. I'm Margaret Lenin, the director of Scripps Oceanography, and I'm talking to you from Southern California, here in La Jolla. You see the beautiful Scripps Pier right off of our oceanographic institution behind me. I am so sorry that I'm not there with you celebrating your Foundation Day, and I promise that when COVID is over, that I am going to come to visit you. In the meantime, I've put together a little presentation for you, and I'm going to share my screen and talk to you a little bit about what I see happening for ocean science in the 21st century. So here we are in the Bay of Bengal in 2018, when a group of our oceanographers were working with some of yours, looking at the impact of the monsoon on internal waves and internal circulation in the Bay of Bengal. So as we think about observing the ocean and ocean science, there have been important stages in oceanography. I think much of the early 20th century was focused on describing the ocean. What is there? What are the currents? What are the ecosystems? How does the ocean interact with the atmosphere? Later in the 20th century, we became very aware that the ocean was capable of change, both natural change and anthropogenic change. So we really looked at determining the variability of the ocean. How does it vary in time and space? More recently, we understand that this variation in time and space also causes variations in the relationship between parts of the ocean and its complexity. So how do ecosystems and physical systems interact, and how do they change? How will they change with the new pressures of human activity and how we affect the ocean? A very famous oceanographer at Scripps, Walter Munk, often described the 20th century as the century of undersampling the ocean, not being able to look with as much detail as we needed to answer the kinds of questions that we wanted to answer. Another great oceanographer at Scripps, Roger Revelle, said that great periods of oceanography are defined by new kinds of instrumentation. And I think that that's what we're in the midst of now. New kinds of instrumentation that are going to allow us to sample the ocean in great detail, to stop undersampling the ocean, and they are going to define a great period of oceanography in the next century. So how do new measurements and rich data sets change our understanding? The first example I'm going to give you is our understanding of the physical ocean. Now, we're used to going to sea on ships using conventional methodologies like CTDs and Niskin casts to understand the ocean. And in the upper right-hand corner there, this will be very familiar to you, those were the ship tracks from the first Indian Ocean expedition. And using those tracks and similar tracks in the Pacific and the Atlantic, we built up a picture of what the ocean looked like, especially what the upper 2,000 or 3,000 meters of the ocean looked like. And that gave us, as we repeated those measurements, we got a sense for how the ocean was changing. And the specific example that I'm going to give you here is about heat in the ocean. So we've known since we started measuring ocean heat about 40 years ago that it was capable of change, and we soon saw that the ocean was warming. Now, the upper panel there with all of those colored lines are 5 different analyses of ocean heat measurements with time. And you'll see that several of them have error bars associated with them. And the last one, the blue one, does not, because it is an analysis of all of the others. And it is this data which shows us that especially since about 1980, that we've had a very good sense of the ocean warming with time. And this is the surface, the upper ocean, the upper 700 meters of the ocean. In the lower panel, you see an orange line. That's the ocean heat from 700 meters to 2,000 meters. And then for less time, we've been able to look deep into the ocean. And that purple curve is for 2,000 to 6,000 meters. So we know that the ocean is warming. And we also, based on that information, have been able to give a little information about where the heat from fossil fuel is going. And it has been clear that most of it is going into the ocean. So the dotted lines are the uncertainty around the measurement of total heat resulting from fossil fuel emissions. The light blue portion is the amount of heat that is going into the upper ocean. That's the upper 2,000 meters. The dark blue is the amount of heat that's going into the deep ocean, 2,000 to 6,000 meters. The little gray line is the amount of heat that is going into the cryosphere. The orange line is the amount of heat that is being taken up by the land. And that tiny line at the bottom in purple is the amount of heat that's being retained in the atmosphere. So much, much more heat from fossil fuel emissions is in the ocean than in the atmosphere. The ocean is protecting us from climate change. And about 90% of the heat from fossil fuel emissions is going into the ocean. But as recently as 6 years ago, when IPCC had its fifth assessment, this was as much as we knew about the distribution of heat in the ocean. As a result of new technology and really dense observation of the ocean, our view is changing. And the little dots on this map show the locations of Argo Floats. Starting in 2000, the international oceanographic community started deploying autonomous floats that send a 2,000-meter water column profile back to land every 5 to 7 days. And India is a very important partner in this. So you have deployed Argo Floats and have been responsible for ensuring their data quality as a contribution to this. So this is the distribution of floats as of today. Today is July 24th for me, and almost 4,000 floats in the ocean. The little picture on the left-hand side are the two men at Scripps responsible for the development of Argo Floats and who presently run the international service that takes all of the data that we receive and does the quality assurance and sends that data out to the world. So how does this work? In the lower left, or in the lower right, you're going to see the deployment of floats over the time since 2000. And you can see that the Indian Ocean was well represented fairly early. That's in 2004 right now. And how do they work? So the floats are deployed from ships. They go into the water and they sink to about 2,000 meters depth. They then float at 2,000 meters depth for about 5 days, and then they come up to the surface, measuring all the way up to the surface, and they send the data back to land via satellite. And those profiles that they take coming up are the sum of our new knowledge of the ocean. Then the float sinks again and goes through that repeat. So every 5 to 7 days, they're sending a float back. So as you can see, now we have a much more dense array of these. So we're really measuring a lot, and we're measuring every 5 days over much of the ocean. So I want to remind you again of that view that we had just a few years ago of where the heat was and how much heat there is in the ocean. Now, based on Argo, we're able to look at this with much greater detail. So this is the globally averaged temperature anomaly. So this is just temperature, not heat, from 2004 until 2020. And this is the upper 2,000 meters of the ocean. So you can see that the ocean is warming with time. You can see the variability as the interannual variability. You can also see that as the ocean heated up, it was the entire upper 2,000 meters that was heating, not only the surface. So that's the temperature. Now we can also look at ocean heat. So this is a map based on the upper 2,000 meters depth heat gain in the ocean from 2006 until 2016. So that's a decade of heating. And now we can see even more detail that although the entire ocean on average is heating, that there are actually some areas that are cooling in the Western Pacific, in the North Atlantic. But overall, the ocean is heating. This is incredibly much more detail than we had even a few short years ago. And it gives us a great example of what happens when we use new technology massively to be able to measure the whole ocean and to measure it continuously. What's up next for these physical measurements? Trying to get the full depth of the ocean, not just the upper 2,000 meters. So this is a new instrument, first developed at Scripps, but now there are instruments developed by 4 other countries, and their goal is to document changes in the deepest parts of the ocean. And recently, a philanthropist in the US provided $4 million to purchase deep Argo floats and add them to the Argo array. So soon we're going to be able to give a picture of the heat with time in the full ocean depth. It's a remarkable change in just a few short years. So these large dense data sets are radically transforming our understanding of the most basic components of the ocean, its temperature, the amount of heat it's taking up, with new insights. Another example of this is sea level rise. So this is our traditional understanding of sea level rise. The blue measurements here are the average sea level change relative to the year 1880 up until this year, 2020. And the light blue around that line is the 95% confidence interval of sea level rise data. And the orange line is the satellite data. And satellites are a major contribution to this. The blue comes from tide gauges, and there are only a few hundred tide gauges around the ocean, but satellites give us a much more comprehensive view. And that's really important because sea level rise is not constant throughout the ocean. And you know that because these are the rates of sea level rise over various areas in India, and the long-term data are the long-term average has been obtained for these areas, but there are different lengths of time series. So Mumbai has 128 years of tide gauge data, while Oka only has about 28 years. But you can see the big difference in the rate of sea level rise over the period of the time series. And if we look at that globally, and this is from satellite data, you can see those patterns very clearly. So this is all of the data from 1993 to May of 2014. And this is the rate of sea level rise. and those are in millimeters per year. So the red colors are 7, 10, 12 millimeters a year. The light blue colors are decreases in sea level of as much as 3 to 5 millimeters a year. So you can see here that over this period of time, the Western Pacific, the Southeastern Indian Ocean, and some of the South Atlantic and South Indian are areas in which sea level is rising much more rapidly than in the rest of the world. So that's from 1993 to 2014. But even during that time, there have been changes in the distribution of sea level rise rates. So these are the data for just the 10 years between 2006 and 2015. And I've expanded the data for the North Indian Ocean there in the lower left. The dots are the tide gauges, and the colors are the altimetry data, the satellite data. And here you can see that it's exactly the opposite as the long time series. So sea level rise has been rising more rapidly in the eastern and equatorial Pacific, and more slowly in the western Pacific and the North Atlantic. So it's exactly the opposite as of the earlier parts of the record, 1993 to about 2006. And that has led us, this was a revelation in terms of our ability to understand how sea level was rising. And that's really important as you think about adapting to sea level rise. So what if people in my area had said, oh, we don't have to worry about sea level rise because it's not rising here, and made no plans for adaptation to sea level rise. And then we went into a different phase and sea level rise is rising rapidly. And why is that happening? We know that the aerial pattern of sea level rise is being moderated by the Pacific Decadal Oscillation. And the warm and cool phases of the oscillation pile up water in different parts of the Pacific. So the average sea level rise is being affected by these global processes in the ocean. And of course, it's also affected by local processes. So in order for us to give good advice to the ministry and to all of those who have to manage adaptation, it's important for us to have synoptic data, spatially distributed data, and also to have time series data. This is sea level rise very close to Scripps oceanography. It's only about 10 kilometers, 15 kilometers south of us. And of course, all of these buildings were built at a time when we weren't having impacts from storm surge like this. But this is a great example of the local conditions. And this isn't happening because of a storm locally. The wave conditions here are being generated by a storm in the Western Pacific. And we were able to track those waves across the Pacific and warn the community that they had to take steps to prepare for the storm surge overtopping the seawalls and shoreline protection. So that combination of being able to look locally but have knowledge of the global ocean is incredibly important, and it's totally dependent on our ability to have rich data sets spatially and temporally. Let's look at one more example, and that's ocean acidification. So we know that the CO2 that's going into the atmosphere is also being dissolved in the ocean. Just as the heat is being taken up by the ocean, about a quarter of the CO2 that's going into the atmosphere winds up in the ocean. And that CO2 is actually lowering the pH or increasing the acidity of the ocean. So the red dots on the top are the Keeling curve, the CO2 in the atmosphere. And the blue dots are from a time series measuring CO2 dissolved in the upper ocean very near Mauna Loa, about 500 miles north of Mauna Loa in the Pacific Ocean. And the bottom curve is the in situ pH measured at the same place. So as the CO2 has been increasing in the atmosphere, it's also increasing in the surface ocean, and it's decreasing the pH, increasing the acidity. So the oceans are 30% more acidic than they were in 1850. And this has been causing difficulty with all of the organisms that secrete shell material or skeletal material out of calcium carbonate. It makes it more difficult for them to make their calcareous shells. And it's, and of course, corals are part of that. And the photograph there is from the Western Indian Ocean, but you can see that around the entire Indian Ocean, especially in the Eastern Indian Ocean and the Coral Triangle, we're concerned about the coral reefs and the sustainability of the coral reefs in the face of ocean acidification. So how can we start to look at this? New technology, again, I'm giving you examples from Scripps Oceanography, a new pH sensor that can be deployed on moorings or deployed on the seafloor, recently won the X Prize competition for new technology for measuring pH reliably and accurately from autonomous vehicles and moorings. And that has given us the ability to now deploy instruments that can measure pH continuously. So we can start to understand how pH is changing, where it's changing. So physical exploration, even with new instruments like these, is often not enough to achieve an understanding. We also need to explore data in time. We need to look in the time space as well as space. And this requires much more data than we're used to having in the past and new approaches to using the data. And I'm going to give you an example from ocean acidification. So how do you start to detect the impacts of individual stressors on a reef? How do you separate the effect of acidification from something like pollution or warming? One way is to look at systematic photo surveys of the reef combined with those measurements of pH. So this is an example of one of our scientists developing a photo mosaic over the Palmyra Atoll in the middle of the Pacific. It's just there above the equator. So thousands of images are converted into 3D photo mosaics. Whoops, went too fast. And this is an example of this. This is not a photograph. This is a digital image made up of data from that photo mosaic and then overlapping. And because the photos overlap, you get this 3D sense. This digital image has almost 5 billion data points, and it allows scientists to look in great detail at the reef to be able to understand how it's changing. And of course, to do that, you have to be able to map this incredibly complex environment, and you have to look at it with time. So this is that photo mosaic, an example of using machine learning techniques to identify the individual types of coral and then map them out. So we work together with people that are experts in machine learning and artificial intelligence, and all the red area there is the distribution of a specific type of coral, a specific species of coral on the coral reef. And we can then do that for all of the different types of coral, map them onto that photomosaic, and be able to look at which types of coral are there, how they interact with each other, and then we can look at these with time. So these are 3 complete photomosaics, and I should have told you this, the area here is about 30 meters by 30 meters. And what you're seeing is the photomosaic, so this is 2014, and then here's a shift to 2015 when there was a coral bleaching event, and then we're going to shift now to 2016, and you can see the coral growth. So this allows us, and we have sensors for pH around that entire coral area. So now we can look at the temperature to look at warming, we can look at pH to look at acidification, we can also measure nutrient pollution and combine it with this time series and spatial look to see which types of corals are being affected and how resilient they are to be able to return after the warming incident is over or after after pH returns to higher values. This allows us to answer new kinds of questions, like what is the total calcium carbonate and the carbon uptake of a healthy reef system compared to one under stress from bleaching or physical disruption or acidification. So we can start to look at the whole carbon balance. How much total carbon is lost during bleaching events across the entire ocean? So how much, how is that affecting the total carbon sequestered by the ocean? How long does it take to recover from an event like that? Which species are most resilient to each stressor, and how do their mutual resiliencies interact in the face of stress? We even are able to look in microscopic detail. So this is an example of a microscope deployed on Scripps Pier. It operates autonomously and it records images of the phytoplankton that it's seeing continuously. So this microscope has generated over 1 billion phytoplankton images to date. Now, obviously, we can't look at all of those individually, so we're developing artificial intelligence and machine learning techniques to be able to look at them, and then to be able to combine them with data on nutrients, temperature, pH, and so forth, to not only know what's happening in general, like there's a phytoplankton bloom or there isn't, but who's responsible for that bloom? And how did the bloom evolve? And what was the relationship between the phytoplankton and the zooplankton during the bloom at the individual species level? So this is what new technology and new deployment of technology has done. So our ocean science capabilities now create new opportunities to answer these complicated questions and responsibilities. So if we have this kind of data, our responsibility is to work with our stakeholders, our governments, whether at the local, the state, the national, or the international level, to do that. And this brings me to the UN Decade of Ocean Science for Sustainable Development. So the UN, led by the Intergovernmental Oceanographic Commission, has specified that 2021 to 2030 will be the decade of ocean science for sustainable development. And it aims to deploy these incredible new technologies very broadly to be able to look at a whole host of questions that are really important for society. And the 6 big societal outcomes that we want to have generated by the end of the decade are: first, a clean ocean. Understand the sources of pollution, identify them, quantify them using these new technologies, and how to remove these pollutants from the ocean by preventing them coming into the ocean. A healthy and resilient ocean. So mapping ecosystems and we, as you saw, we now have incredible tools to be able to map in great detail. Be able to look at multiple impacts, like the examples that I gave you of warming versus acidification versus pollution, including climate change. We'll measure them and be able to understand how ecosystems are responding and what tools are most important for us to have a healthy and resilient ocean. The third is a predictive ocean. And by this we mean that society has the capacity to understand current and future ocean conditions and to absolutely be able to forecast their change and impact on human well-being and livelihoods. So to be able to take those changes that we see in heat or in sea level rise or in acidification, project them into the future in a really reliable way and be able to understand what we need to do to mitigate and to adapt. The fourth societal goal is a safe ocean, protecting human communities from ocean hazards, whether those are tsunamis, monsoons, typhoons, hurricanes, severe storms, and so forth. And to be able to do that in a way that predicts those hazards to the best of our ability and gives communities tools to operate safely at sea and operate safely in the coastal zone. The fifth is a sustainable and productive ocean. So the provision of food supply from the ocean and alternative livelihoods are secured. Understanding how, our fisheries, whether they're commercial fisheries or artisanal fisheries, and being able to put in place techniques and policies for sustainable and productive ocean. And then finally, what we call a transparent and accessible ocean, that all nations, all stakeholders, all citizens have access to that ocean data that I've talked about and to information technologies to allow them to make good decisions about the future. So these are the goals of the decade, and I think that you can see that we have some incredible tools now to answer these questions, and that over the decade we'll develop even new technologies and deploy these over the entire ocean to be able to reach these societal goals. So with that, I'll say thank you. I know that India is a tremendous partner in developing these new technologies and in deploying them, not only in the Indian Ocean, but around the world. So thank you for everything you're doing to make the 21st century a century of ocean science for sustainable development, not just in this decade, but in the next 100 years. And again, thank you so much for the invitation to speak to you. And I apologize that I'm not there in person, but I will get there as soon as I can. Thanks very much from me and from all your colleagues at Scripps Institution of Oceanography.
So on behalf of the Ministry of Earth Sciences, I thank Dr. Margaret Lenin for the very informative and interesting lecture on the ocean sciences in the 21st century. With that, we come to the end of this Foundation Day function today. And I would like to thank my colleagues, Dr. Nilay Khare, Dr. Jagveer Singh, Shri Naveen Shah, Shri Anuj Daya, Shri Murthy and his NIC colleagues, Shri Pramod Kumar and Shri Raman for helping in organizing this MoES Foundation Day function 2020. Thank you. Jai Hind. Huh? Thank you.